Not all growth follows an exponential model, and particularly ones that have a restriction to them follow a logistic function. So we're going to talk about that. So logistic function, here's what the equation looks like. The graph looks something like this. And we're going to have an asymptote here, and you have an asymptote here. So if you think about a situation like an island filled with bunnies, eventually they're going to run out of grass and other vegetation, and there's going to be no more resources for the little bunnies, and their population is going to start leveling off. We use a logistic function to model that kind of growth, where there's an upper limit, which you can see here, where it starts to level off at the upper asymptote. So looking at some of the characteristics of this function, we have the domain is all real numbers, unless the problem implies that there's, some other domain restriction, like you can't have negative bunnies or whatever. There are typically no x-intercepts, again, because we shouldn't fall into like negative values for things. Is it continuous? Yes. Is it increasing? Always. So from negative infinity to positive infinity, unless it was decay, and then it would be always decreasing. We don't mention any maximums and minimums. They don't really exist here. We do have our horizontal asymptotes at y equals 0 and at y equals c, which, if you remember from the previous slide, when we generalize it, we get a constant c up here, which is the limit of growth. So if our island can only sustain 5,000 bunnies, that's the limit of growth, is 5,000. So we get an asymptote at that upper limit. And for the end behavior, I'll write this out in limit notation this time. The limit as x approaches negative infinity, f of x approaches 0, we get that asymptote at the bottom. And the limit as x approaches positive infinity, f of x is going to get really close to c. It's another way of describing those asymptotes, more or less. Okay, so let's try this one. Just numbers, just looking at the equation. So we know we have c, there we go. There's our generalized growth function. All right, so we have an initial value of 10. We have a limit to growth of 40, and we have a 0.120. So I'm going to set up a couple of equations. Feel free to pause to copy down what I write. Okay, so there's what our function looks like so far. Then we have some information to plug into it. So switching colors again, we get f of 1 is going to equal 40 over 1 plus 10 times b to the 1, that's our x value, which also happens to be equal to 20. So now we can solve for our b value. We have everything else filled in except for b. So let's solve for that. Okay, so multiplying both sides to get rid of the fraction, I get 40 equals 20 times 1 plus 10b. So then isolating what we have in the parentheses, we get 2 equals 1 plus 10b. Then trying to get b by itself, we're going to get 1 equals 10b. And so we're going to get 0.1 equals b. And so then we would be able to plug that back in here, and we would get our complete logistic function for the situation. So logistic functions also happen on in places that aren't islands filled with bunnies. We've talked about San Jose's population. We could also talk about Dallas, the fact that there are other geographical concerns that prevent Dallas from continuing to grow. So we could use a logistic function to model its growth. And so we get, based on some census data, we get a logistic function that it looks real hairy, so it's not something I would expect you to produce. But let's take a look at the graph of this. Okay, here's what the graph looks like. We were asked about, here's what the graph looks like. We were asked to find when the graph will be 1 million. So we're going to type that in there. And we see our intersection here at 88.05 years is when they will hit 1 million. Okay, so here's what I want you to try on your own. We have a logistic function modeling a rumor spreading. How many students, 2 questions, how many students will have heard the rumor after the 5th day, and how many days until 1,000 students hear the rumor?